Okay, this is the Unit 4 study guide. I'm going to go over it. Number one, first topic is solving by graphing. You have to put those into slope-intercept form. So when you move the first one around, you get y equals negative x plus 2. That's this line right here. And then you get y equals x minus 4. That's this line right here. They intersect at the point 3, negative 1. That's your solution right there. That means that this point would make each of these equations true. Number two, you rearrange those. This one's already in slope-intercept form, the y equals 2x plus 4. This one gets rearranged to y equals 3/5 x minus 3, and your solution is negative 5, negative 6. Number three, you rearrange the first one to get y equals 1/4 x minus 7. The second one to get y equals negative 1/2 x minus 1. The intersection's way over here at 8, negative 5. Number four, when you rearrange these, you'll see that the slopes are the same. They both have the slope of 4/3 x, but different y-intercepts, which means they'll never intersect, so that one is no solution. Topic 2, solving by substitution. This is best to use when you have an x or a y that's already isolated. So I'm going to plug in this expression for that y, and then I'm going to solve. And then plug in for the other one. So I have negative 4, negative 5. This one, I took what y is equal to, and I plugged it in the other one for y, right here, and I distributed. I got a y value of negative 2. Then I plugged that y value in. I'm sorry, I got an x value of 5. Then I plugged the x value in right here, solved, and I got y is negative 2. So my solution is 5, negative 2. This is substitution again. So in order to do that, I isolated one of the x's. I did the second one, x equals 2y plus 1. Then plugged it in up here for the x. I solved for y, I got 3. And then I plugged it into the other one, solved for x, and got 7. So my point is 7, 3. Number 8, I isolated y in the first equation, moved it around to get y equals 6x plus 21. Then plugged it in here where the y is. I solved for x, got negative 2. Then plugged that into the first one, and I got 9. So my point is negative 2, 9. Now it says elimination, which seems to be some of your favorites. So I multiplied the top one by 3 so I could eliminate the 3 x's. Solve for y, I got 4. Then I plugged in the 4 for y and got negative 1 for x. So my points are negative 1, 4. The next one, you have to multiply both of the equations. You might have used the other numbers, but I multiplied the top one by 5 and the bottom one by 2. And after that, I eliminated everything, so I got the same thing on either side. So that is all real numbers or infinitely many solutions. That means anything you plug in is going to make both of them work. Number 11, I multiplied the top one by 3 to eliminate the 3 y's. So then when I solve for x, I get 2. Plug that back in, solve for y, I get negative 5. So 2, negative 5. 12, let's see, I multiplied the top one by 2 so I can eliminate the 2 y's. I solve for x, I get negative 3, and then plug in the negative 3, and I got y is negative 8. So my solution is negative 3, negative 8. All right, these are word problems which seem to scare some of you. 13, a tennis coach took his team out for lunch and bought 8 hamburgers and 5 fries for $24. The players were still hungry, so the coach bought 6 more hamburgers and 2 more fries for $16.60. What is the cost of a hamburger? So first, I defined my variables. I made x for hamburgers, the cost of a hamburger, and y, the cost of fries. So the first time, here's my 8 hamburgers, 5 fries, and they're $24. 6 hamburgers, 2 fries, $16.60. I chose elimination. I multiplied the top one by 3, the bottom one by 4. And when I solve for x, hamburgers are $2.50. Once you get past setting these up, they're easier. 14, Jim sells hot dogs for $2.95 each and steak sandwiches for $9.95 each out of his food court. During a busy outdoor festival, he sold a total of 985 items for $7,343.75. How many steak sandwiches did he sell? Well, I made x the number of hot dogs and y the number of steaks. So if you add both of those together, there were 985 total. The hot dogs are $2.95, steak sandwiches are $9.95, and here's the total money. Okay, so now I isolated x here. I used substitution and then plugged it into that equation and solved for y. So y is the steak sandwiches, so there are 634 of them. And you don't need to do anything else because that's all they're asking for. 15, Bob bought 24 hockey tickets for $83. Adult tickets are $5.50 and child tickets are $2. How many child tickets did he buy? Here's his total tickets, and here's the price and what he spent. When you isolate x here, I mean, you can use elimination if you want. So when you solve for y, you get 14, and that already gives you the child tickets. So 14 child tickets. 16, Ethan makes $6 per hour mowing lawns and $7.50 per hour bagging groceries. Last week, he made a total of $129. The difference between the number of hours bagging groceries and the number of hours mowing lawns is 10. That's right here. Here's how much money he made total. Let's isolate y right here. Solve for x, which is 4, and that's 4 hours mowing. Okay, I think this is the last one of the word problems. Dustin has only nickels and quarters in his piggy bank. He has 49 coins total for a combined value of $8.85. How many of each type of coin does he have? Well, total coins, nickels and quarters, is 49 coins. Here you have to put the value, 5 cents for the nickels, 25 cents for the quarters, for a total of $8.85. We isolated x here, and then we plugged it in right there and solved for y, which is 32 quarters. Then you're going to plug your y back in up here to get your 17 nickels. All right, here are your linear inequalities. Remember that if it's less than or greater than, your line is dashed. If it's or equal to, your line is solid. So you're going to rearrange this to slope-intercept form. We're going to graph it, and when we pull our test point, we're going to plug it in to see if it's true. So 0 is less than 6, so we colored the test side with the test point in it. Number 19, x is greater than or equal to -3. That is a horizontal line. 0 is greater than 3, so you're going to color the side with the test point. Here's the system of equations. When you graph both of these, their intersection is right here, so that's your answer. 21, you have to move those into slope-intercept form. Remember to flip the sign. So here is my intersection right here. We're back to graphing regular systems, not inequalities. You move them into slope-intercept form. We have y equals -3x plus 5 and y equals -x minus 1. Your intersection is 3, -4. Here, this one's in slope-intercept form. Y equals 2x plus 4. This is y equals -2x plus 4. Here's my intersection at 0, 4. Let me see. This is substitution. For this one, we're going to isolate y and then plug it in here where y is. We're going to solve for x. We get -1, and then plug that -1 into the other equation where x is to get my y. So I have -1, -1. This time, I isolated x, and I plugged it in to the second one right there. I solve for y to get 5. Now I'm going to plug that 5 in, the other equation up here, and I got x is negative 9. Negative 9 and 5 is the answer. This one's elimination. So I multiplied the top equation by 5 so I could eliminate the 5x's. I solved for y, I got 1. And then I plugged that back in to get x, which is 1. So 1, 1 is my answer. Number 6, I multiplied the top 1 by 3, bottom 1 by 2. That way I can eliminate the 6's. I solved for y, I got 2. I plugged y back in to get x is 7. So my point is 7, 2. We're almost done. We're back to the word problems. Karen and Holly took their families out to the movie theater. Karen bought 3 boxes of candy and 2 small bags of popcorn and paid $18.35. Holly bought 4 boxes of candy and 3 small bags of popcorn and paid $26.05. What's the cost for candy? So if you define these, you're going to have an easier time. So I made X candy and Y popcorn. So here's Karen with 3 boxes of candy and 2 bags of popcorn, and she spent $18.35. Holly, 4 boxes of candy, 3 boxes of popcorn, and she spent $26.05. I used elimination because there's no variables alone, so multiply the top one by 3, the bottom one by 2, and X, which is candy, is $2.95. Number 8, Mr. Delaney broke his piggy bank with a sledgehammer and found that it only contained quarters and pennies. If he had a total of 120 coins, that's all of the coins together, that's right here, and then he adds the value of the quarters and the pennies to be 1632. So we're going to let X be the quarters and Y be the pennies. This time I use substitution because I have an X without a coefficient. So I isolated X here, and I'm going to plug it right in there and solve for Y. So Y is 57 pennies. Some inequalities again, we put them into slope-intercept form, making sure that we flipped the sign right here when you divided by -4. So I have y equals 1/2 x minus 2. I used a dashed line. And then I tried my test point, and it's true, so I colored the side with the test point in it. This time I have y is greater than or equal to -3, so that's a horizontal line going through -3. It's solid because it's or equal to. Here's my test point. 0 is indeed greater than -3, so I color the side with the test point. Here's my systems. We graph both of them, and the overlap is your solution right there. They label it with an S. Feel free to do that. You got to rearrange these to slope-intercept form, and here's the overlap for that one. So I just have to be able to see what the solution is. All right, make sure you check in with me if you have any questions.